So we are going to discuss about new approach for calculation of valence quark distribution in the nucleon, and main idea that effective number of valence quarks are conserved, and because of this, we can introduce concept of strong mean field, and the problem actually becomes kind of known problem of fermions in the external mean field. Now the mean field is generated by the nuclear medium or residual system, where if you look at the left side picture, basically we approximate with some effective mean field of it. Now, our goal is to calculate this diagram in the left one, for which we use effective diagrammatic approximation, introducing some characteristic of the mean field and applying all the known rules and calculating actually structure function from which we can extract structure function of valence quarks. Now, calculation of this diagram done, as I said, in a light front, introducing light front wave functions here, actually, which are basically we kind of put all the non-perturbative parts, which we don't know how to calculate, in introducing effective wave function. What we do next, then we calculate structure function Wn, and then eventually obtain expression for the partonic distribution. And then we have to model these two non-perturbative wave function. And for valence quark, three-quark system, we use coupled channel relativistic harmonic oscillator model. And for residual system, we introduce kind of Gaussian model. And then they are all described on a light front reference frame. Now, after doing the calculation, it's kind of we end up more or less in a simple formula if you look actually massless limit, and then few qualitative properties of this calculation such that it actually predicts in a model independent way that peak of this distribution is proportional or related to the recoil mass of the system, and actually it's beautifully explained why actually peak corresponding of the U quark is larger than peak corresponding to the D quark. Now, another qualitative feature that this mean field model actually predicts that distribution should depend on X-Bjorkenman approach to 1, like a power of 4, not a 3. So it's interesting. And then finally, we can actually predict its actually value at X going to 1, just if mean field will dominate. So what we do, we fit this model into existing partonic distribution, extract all the parameters, and one interesting thing that in our model, we predict that dV over the UV ratio goes to 0.21. Finishing, I want to kind of say that we got all the wave functions, and this will allow us to calculate any processes we want to do, including exclusive reactions, semi-exclusive GPDs, PMDs. So that then our next goal that we phenomenologically can do calculation of practically all the measurements which